Today we are going to open the black box that every Git user has on their machine, but almost nobody looks inside. The .git folder. It's just files and directories, no magic. By the end of this video, you will understand exactly what Git does under the hood, and you will be able to recreate it yourself from scratch. Let's start with the most basic action, git init. Run it in an empty directory and Git creates a .git folder. Let's look what's inside. Just one thing, I will remove unnecessary files for clarity. The actual .git contains a few more files, but these are not important ones. You can see a few things. Objects folder, this is where all the data lives. Refs folder, this is where branches and tags are stored. And head, a single file that tells Git which branch you are currently on. Everything else, hooks, config, description, is supporting infrastructure. Let's zoom in on objects folder because that's the heart of it all. Git stores everything as objects. Every file, every directory snapshot, every commit. Each object gets a unique identifier, a hash, computed from its content. By default, Git uses SHA-1, which gives you a 40 characters hex string. Since Git 2.29, SHA-256 is also supported. 64 characters, more collision resistant. The first two characters of the hash become the directory name, and the rest becomes the file name inside it. So an object with hash abc123 lives at .git/objects/ab/c123. Objects are stored compressed, and they are immutable. Once written, never changed. Now, what kinds of objects does Git actually store? They are exactly four types. A blob, raw file content, no file name, no metadata, just bytes. A tree, a snapshot of a directory, lists file names, permissions, and pointers to blobs or other trees. A commit, a snapshot in time, points to a tree, has a parent commit, author, message. And a tag, an annotated tag object, which we will get to later. Four types. That's the entire Git data model. Before we run git add, let's understand what Git actually does internally when it comes a blob. The algorithm is simple. Take your data, prepend a header, the word blob, a space, the byte count, and the null byte. Then compute the SHA-1 of the whole thing. That hash is the object's identity. Finally, compress the content with zlib and write it to .git/objects. This is exactly what git hash objects does internally. Same input, same output every time, content addressed storage. Now let's actually run git add and watch what happens to .git folder. I have an empty file. I stage it. Look, a new directory appeared inside objects, E6, and inside it a file whose name is the rest of the hash. That's the blob object Git just created for our file. Also notice the index file, that's the staging area. It maps file names to blob hashes. It's what git status reads. And here is the plumbing command that git add wraps. Git update index --add. Same effect, adds the file to the index and writes a blob to objects folder. We now have an object in the store, let's inspect it. The most direct way is to list files on disk. This shows everything, including staged blobs. There's also git ref list command, but watch out. It only shows objects reachable from commits via refs. A staged blob has no commit pointing to it yet, so it won't appear here. Use it after committing. To see what's currently staged and which blob hash each file maps to, run git ls file. Now let's ask Git what type an object is and what it contains. This works for all four object types. Cat file is your X-ray into the Git object store. Remember it. Now let's commit and see what changes. 3 objects now instead of 1. The blob we already know. A new tree object, it records a directory snapshot. And new commit object, it points to the tree, records the author, message and timestamp. Also notice ref/head/main file appeared. It's just a file containing a commit hash. Logs folder appeared where Git records the history of changes to refs. This is how Git reflog works. And a file commit edit msg which contains the commit message for the last commit. Let's recreate a full commit using only plumbing commands. No git add, no git commit. This is how Git works internally, step by step. At the beginning I will create a new file and I will add it to the index and I will verify if the index is updated. Awesome. Let's now add the content to this file and update index one more time. After staging a file, let's create a commit. I need to run command git hash object, which will write a blob. Then I need to run git write tree. It will snapshot the index into the tree object. After that, I need to run git commit tree, passing this previously created tree as a parameter, plus required commit message. Then I need to run git update ref. 4 commands. That's all git commit does. To confirm that creating commit finished successfully, I will run git status and git log to see history of commits. A branch in Git is just a text file. It lives at .git/ref/heads and contains a single commit hash. That's it. No complex structure, just a pointer. Git update ref writes that pointer. Let's create a new branch called feature that points to the current commit. That's it. To see all branches, you can just list the files in .git/ref/heads folder. Each file is a branch. Switching a branch means changing what head points to. Head is a file that contains a ref, like ref:/head/main. Git symbolic ref rewrites that file. Let's switch to the feature branch we just created. Excellent. Now head points to ref/heads/feature, and we are on the feature branch. Deleting a branch removes the ref and its history log. After git update refs -d, the ref is gone from .git/ref/heads. The commits themselves are still in objects folder. They are just unreachable now. Tags are just like branches, refs pointing to a commit. A lightweight tag is literally a file in .git/refs/tags folder. So let's create a lightweight tag called v10 that points to the current commit. Before that, I will confirm that there is no any tag created before. You see, the folder .git/refs/tags is empty. So let's create a new tag. And now we have a tag v10 that points to the same commit as head. An annotated tag is different. It's a full Git object stored in objects folder, just like a blob or commit. It contains the tagger identity, timestamp, message, and optionally a GPG signature. Creating one manually means writing a tag object first, then pointing the ref to it. Here is the key difference you can verify right now with cat file. A lightweight tag, cat file -t, returns commit. It points directly to a commit. An annotated tag, cat file -t, returns tag. It points to a tag object, which in turn points to a commit. One extra level of indirection, but much richer metadata. Now that you understand every file in directory in .git folder, let's prove it by creating a valid Git repository from scratch, using nothing but mkdir and echo commands. That's a working Git repository. No git init, no magic, just a minimum structure Git needs to function. The objects directory, the refs directory, and head file. Everything else Git creates on demand. On the next page you will find links to resources where you can learn more about Git internals and practice with plumbing commands. First link is interesting. It's a wrapper around Git plumbing commands designed for educational purposes. It gives you a more user-friendly interface to explore Git internals. That's wrap. The .git folder is just files, hashes, compressed blobs, and text refs. Next time Git does something unexpected, you know exactly where to look. If this was useful, subscribe and check out the resources below. See you on the next one. Bye bye.